Welcome to Orbit Observer. Tonight I want to take you somewhere very far away and very cold and very quiet, and I want us to go there slowly. There's no hurry at all. Wherever you are right now, whatever kind of day is finally letting go of you, you can set it down. You don't have to hold on to any of it. Let your shoulders drop a little. Let the weight of your own head settle into the pillow. We're going to drift out past everything familiar, past the warm little cluster of planets you already know by name, out to the far edge of the sun's reach, to a small frozen world with a heart on its surface. And that heart is doing something almost impossible to believe. It is erasing itself. Picture it for a moment. A pale, distant world, so far from the sun that the sun itself is barely more than a very bright star in its black sky, a pinprick, a spark, not the great warm lamp we feel on our own faces. And across the face of this little world lies an enormous bright shape, smooth and pale, unmistakably the shape of a heart. It sprawls across a huge stretch of the surface, glowing softly against the darker, redder, older land around it. And here is the strange thing, the thing I keep coming back to. On the smooth left side of that heart, there is not a single crater. Not one. On a world that has been sitting out there in the dark for 4.5 billion years, being pelted by debris the whole time, there is a region the size of Texas, with a face as blank and fresh as new-fallen snow. Every other ancient surface in the solar system keeps a record. Our own moon is a museum of scars, every crater a story, some of them billions of years old, preserved because nothing up there ever smooths them away. That's the normal way of things out in the cold. A crater lands, and it stays, more or less, forever. But this bright heart on Pluto keeps no record at all. And the reason is almost tender in how gentle it is. The whole surface renews itself. It repaints itself over and over on a cycle that scientists estimate at somewhere around 500,000 years, perhaps a little less. 500,000 years to wipe the slate completely clean and start again. Now 500,000 years sounds like an eternity to you and me. It is longer than our whole species has existed in anything like its present form. But to a planet, to a world that measures its life in billions of years, 500,000 years is nothing. It is the blink of a sleepy eye. It is geologically now. It means this surface is not some frozen relic left over from the birth of the solar system. It is being made, right now, tonight, while you lie here listening. Somewhere out there, on the smooth pale plain of Pluto's heart, the ground is quietly turning itself over, folding old surface under and lifting new surface up, and it will keep doing that long after every one of us is gone, and long after our children's children are gone, patient and slow and utterly indifferent to whether anyone is watching. And that's the thing that stops me. Everything the cameras captured, every ridge, every soft polygon, every gentle seam across that frozen plain, all of it is temporary. All of it is a single frame of an impossibly slow film. Give it enough time, and every feature we photographed will be gone, pulled back down under the ice and replaced by something new. We will almost certainly never see that particular arrangement of the surface again. What we have is a snapshot of one moment in a story that has no beginning we can see and no end we will ever live to witness. And we got that snapshot at all only through the most extraordinary long shot of a journey. Because for most of human history, Pluto was nothing more than a smudge. A faint moving speck of light discovered in 1930 by a young man named Clyde Tombaugh, who found it by comparing photographic plates of the night sky, patiently flicking back and forth between images, looking for the one tiny dot that had shifted against the fixed stars. That was all Pluto was for 85 years. A dot. A point of light so faint and so far that even our best telescopes could resolve it into little more than a blurry, pixelated ball. We knew almost nothing about its face. We could only guess. And then we sent something to look. On the 19th of January, in the year 2006, a small spacecraft called New Horizons lifted off the Earth. It was not a large machine, about the size of a grand piano, if you want something to picture, but it left our planet faster than anything we had ever launched, and it began the longest kind of patience a machine can be built for. It crossed roughly 5 billion kilometers of empty space. It fell outward for 9.5 years. Think about that stretch of time. A child born the week that probe launched would have been most of the way through primary school before it arrived. It flew and flew through the dark past Jupiter, out beyond the orbits of the giant planets, into a part of the solar system no camera from Earth had ever visited, carrying with it, tucked into its frame, a small portion of the ashes of Clyde Tombaugh himself, the man who found the dot, riding along at last to see the world he discovered. And then, on the 14th of July 2015, which, as it happens, was exactly 11 years ago to the very day, New Horizons finally arrived. It did not stop. It could not stop. It was moving far too fast for that, streaking through the Pluto system at around 14 kilometers every second. There was no slowing down, no going into orbit, no second chances. It had one pass. One single opportunity, sweeping to within about 12,400 kilometers of the surface at closest approach. Closer to Pluto than some satellites are to the Earth, and in those few precious hours it turned every instrument it had toward that little world and drank in as much as it possibly could. Photographs, measurements, the composition of the air, the shape of the mountains, the color of the ice. It gathered a treasure of data in a single hurried, glorious flyby, and then it was past. And Pluto was already shrinking behind it into the dark again. And here is a detail I find almost unbearably poignant, in a quiet way. All that data could not come home quickly. Pluto is so far away, and the spacecraft's radio so faint, that the information trickled back to Earth at a rate of only 1 or 2 kilobits per second. That is slower than the very first home internet connections many of us can still remember, that patient electronic warble, the sense of waiting while something loads. Except this download did not take minutes. It took 16 months. The spacecraft whispered its findings home a little at a time, all the way through the rest of 2015 and deep into the following year, not finishing until late October of 2016. A radio signal from out there takes about 4.5 hours just to cross the distance to us, traveling at the speed of light the entire way. So every image arrived old, in a sense a postcard from a place so remote that even light grows tired making the trip. But oh, what those postcards showed. Because when the first sharp pictures came in, and the scientists gathered around their screens to see this world clearly for the very first time in human history, they found that great, bright heart. And they gave the whole heart-shaped region a name to honor the man who found the planet. They called it Tombaugh Regio. Tombaugh's region. His heart, in a way, laid across the face of his discovery, and the smooth, crater-free western half of that heart, the part that repaints itself, the part with no scars at all, they named Sputnik Planitia. A vast basin, a great low plain roughly 1,000 kilometers across, filled not with rock, not with water ice like the mountains, but with something stranger and softer sitting 2 to 4 kilometers below the level of the land around it, like a frozen sea that had settled into a shallow bowl. And this is where the mystery begins to open beneath us, like a trapdoor swinging slowly open in the dark. Because it was not enough that this heart was beautiful. It was not enough that it erased itself. The heart turned out to be sitting in a very particular, very suspicious place. And no one, to this very day, tonight, right now, no one can agree on what lies underneath it. Before we go down into that mystery, though, let me just say, I'd love to know where in the world you're listening from tonight. It's one of my quiet pleasures, reading through the places. Someone lying awake in a city that never quite goes dark. Someone in a farmhouse where the only sound is the wind. Someone on the other side of the planet where it's the middle of a bright afternoon and this is playing softly in the background of something else entirely. Leave the name of your corner of the world down in the comments if you feel like it. And if you're new here, if you've just drifted in and found this a comfortable place to rest, you're very welcome to subscribe so we can keep taking these slow journeys together. But there's no pressure at all. You don't have to do a single thing tonight except breathe and listen and let yourself grow heavy. So, the position of the heart. Let me tell you why it troubles people so. Pluto is not alone out there in the dark. It has a companion, a large moon named Charon. And Charon is so big compared to Pluto, nearly half its size, that the two of them behave less like a planet and its little satellite, and more like a pair of dancers holding hands, spinning slowly around a shared point between them. They are locked to each other. The same face of Pluto always looks toward Charon, and the same face of Charon always looks back at Pluto, the two of them forever staring, turning together through the long, cold centuries. It's a very old, very patient waltz. And a dance like that draws a line, an invisible axis running straight through both worlds, the line along which they hold each other. Scientists call it the tidal axis. It's the spine of their embrace. And when the researchers looked carefully at exactly where the heart sits on Pluto's surface, they found something that made them pause. Sputnik Planitia, the smooth self-erasing lobe of the heart, is sitting almost precisely on that tidal axis, very nearly on the exact opposite side of Pluto from Charon, tucked into just about the one spot on the entire globe that the geometry of the dance would single out as special. And that is a strange place for a great basin to end up purely by accident. Out of all the millions of square kilometers on Pluto's surface, where a feature that size could have formed, it landed dead on the line. It's the kind of coincidence that makes a careful scientist narrow their eyes. Once, maybe, you shrug and call it chance. But sitting exactly on the tidal axis? That starts to look less like an accident and more like a fingerprint, a clue left behind, a sign that something arranged it there. And that is the crime scene, if you'll let me call it that. Gently, softly, nothing frightening about it. The heart is not just a pretty shape, it is a piece of evidence. Its position is testimony. And the question the scientists have been asking, ever since those first sharp images came home, is this: what could possibly have placed a basin so perfectly on that line? What force, what event, what hidden thing beneath the surface could have nudged this feature into exactly the spot where the geometry of Pluto and Charon says it ought to sit? And when they went looking for the answer, they found not one explanation, but two. Two entirely different stories, and the two stories cannot both be true. Just a quick reminder before we sink deeper into this, and then we'll go right back to the heart. I promise. After years of my own nights spent lying awake with a mind that simply would not stop turning, deep sleep finally became something I could actually reach again. And everything got easier once it did. Things I wanted to learn stayed in my head. My energy came back, the real kind, not the kind you fake with another cup of coffee. My thoughts felt clear instead of foggy. Sleeping like a baby, night after night, genuinely changed everything for me. If you'd like the exact approach that made that possible, it's waiting for you in the pinned comments. Whenever you want it. There's no rush. It'll keep. And now, back to the heart and the two stories buried underneath it. The first story is the one that came together in 2016. In the months after the data finished trickling home. And it is a story about a hidden ocean. Here is the reasoning, and I'll take it slowly, because it's a beautiful piece of thinking and there's no reason to hurry through it. The scientists asked themselves how a basin could come to rest on the tidal axis, and they realized that the whole planet might have rolled. Not spun, exactly, rolled, reoriented. There's a lovely, strange idea in planetary science called true polar wander, and the picture behind it is this. If a world develops a heavy spot, an extra concentration of mass somewhere on or under its surface, the spinning of the planet will slowly, over long ages, drag that heavy spot toward a particular position, the way a slightly unbalanced wheel will always come to rest with its heavy part hanging at the bottom. The extra weight wants to settle into the place the physics prefers, and for a world locked in a dance with a big moon, the place the physics prefers turns out to be right along that tidal axis. So the idea was this. The heart formed somewhere else on Pluto. And then, because it carried extra mass, the entire planet very slowly turned itself over enormous stretches of time, until the heavy heart had migrated all the way around to sit exactly where we now find it, on the line between Pluto and Charon. The whole world rotated beneath its own skin to bring the heart home to the axis. It's a magnificent thing to imagine, a planet quietly rolling over in its sleep, so slowly you could never see it move, taking millions of years to turn one bright feature from where it began to where it belongs. But there was a problem, a real, stubborn problem, sitting right at the center of the idea. For the whole planet to roll that way, the heart had to be heavy. It had to be a place of extra mass, a positive lump of weight pulling the planet's balance toward it. And the heart is not obviously heavy at all. Remember what it is. Sputnik Planitia is a basin, a deep, low bowl sitting 2 to 4 kilometers below the land around it. A hole in the ground, more or less. And a hole in the ground should weigh less than its surroundings, not more. Where the crust dips down, there is less material, and less material means less mass. And less mass is exactly the opposite of what you need to make the planet roll. So the basin should have pushed the heart away from the tidal axis, not pulled it toward it. The evidence and the explanation seem to be pointing in opposite directions, and that is precisely the kind of contradiction that keeps scientists up at night. A puzzle where the obvious answer is upside down. And it was in solving that contradiction that they reached for the ocean. Because there is a way to make a deep basin heavy, a way to turn a hole in the ground into an excess of mass, and it involves something hidden far below. Something we cannot see. Something that, if it's really there, would change everything we think we know about that little frozen world. And that hidden thing, and the rival story that says it may not be there at all, is where we're going next. But for now, just hold the picture in your mind, the way you'd hold something warm. A pale world at the edge of the dark. A bright heart on its face, keeping no scars, repainting itself over and over across the slow centuries. A heart that has somehow rolled its way to exactly the wrong place, or exactly the right one, and now sits on the line of an ancient dance, keeping a secret in the cold beneath it. 2 stories waiting underneath. And only one spacecraft, long since past and gone, that ever came close enough to see any of it at all. We'll go down into what's beneath the ice in just a moment. There's no need to stay awake for it. Wherever this finds you, whatever hour it is in your part of the world, you can let the frozen plain go soft and blurry now, the way the surface itself goes soft and turns itself under. The heart will keep beating out there, whether we watch or not, and it has been very patient for a very long time. It can wait for us to rest. Only one spacecraft ever came close enough. Let that sink in for a moment, the loneliness of that fact. Across all the years humans have looked up and wondered at that faint point of light, exactly one machine has ever reached out and touched the edge of Pluto's world with its cameras, and it did so for a single afternoon, and then it was gone. New Horizons. It had left Earth back in 2006 and fallen outward through the dark for 9.5 years, across nearly 5 billion kilometers, a distance so large the numbers stop meaning anything and become a kind of music instead. And on the 14th of July in 2015, it finally arrived. Not to stop, not to circle, just to pass. It swept over the surface at something close to 14 kilometers every second, coming as near as roughly 12,500 kilometers above the ice, which sounds far until you remember it had crossed billions to get there, and then it sounds like a whisper against a cheek. There was no slowing down. A probe moving that fast, that far from home, cannot stop. It could only fall past, wide-eyed, gathering everything it could in the few hours the geometry allowed, and then continue on into the deeper dark beyond, still going now, carrying its afternoon of memories away from the sun forever. And here is the part that undoes me a little. Every time. The pictures did not come back all at once. They could not. The signal from that distance is so faint and the data so heavy that the spacecraft could only trickle it homeward at something like 1 or 2 kilobits a second, slower than the oldest modems some of you will remember, that patient electronic sighing of a machine trying to connect. A single radio whisper from Pluto takes about 4.5 hours just to reach us, crawling at the speed of light and still taking half a day. So the full portrait of that world came back to Earth, not in an afternoon, but over 16 long months, arriving piece by piece, a little more of the heart resolving out of the noise each week, all the way into the following autumn. We met Pluto slowly, which feels, somehow, like the right pace for a thing this old. The man who found it never saw any of this. Tombaugh discovered Pluto in 1930, a young man comparing photographic plates by lamplight, looking for the faint dot that had moved against the fixed stars, and he found it, a smudge of light no one had ever named. He died before New Horizons launched. And so the people who built the spacecraft did something quiet and lovely. They carried a small portion of his ashes aboard it, which means that when that machine crossed over the ice on that July afternoon, a part of the man who first saw Pluto as a moving speck was finally there in person, passing over the world he had pulled out of the dark 80 5 years before. And the bright heart at the centre of it all, that vast pale Valentine, was given his name. Tombaugh Regio, his region, his country on a world he could only ever see as a point of light. I like to imagine the comments on a night like this fill up with people from everywhere. So before we go down beneath the ice, tell me, where in the world are you listening from tonight? What hour is it where you are? What season? What kind of dark is outside your window? I read them, all of them, and there is something steadying about knowing that while I talk about the loneliest heart in the solar system, there's a whole quiet crowd of us scattered across the earth, awake or half awake in the same story. And if you're new here and you'd like more nights like this one, you can subscribe, and the next slow journey will find you when you need it. Quick reminder, after years of lying awake with a racing mind, deep sleep finally became possible. Now learning comes easier, energy is real, and the mind stays sharp. Sleeping like a baby changed everything. If you want the exact system that made this possible, check the link in the pinned comments. Now, back to the ice, and to the strange fact we've been circling. The heart that keeps no scars, sitting exactly where it should not be. Because you have to understand just how much that position bothers the people who study it. Sputnik Planitia, that smooth western half of the heart, the true engine of everything. A basin of nitrogen ice roughly 1,000 kilometers across, about the size of Texas, sunk 2 to 4 kilometers below the land around it, does not sit just anywhere on Pluto. It sits almost precisely on the line that connects Pluto to its great moon, Charon, nearly on the far side from it, on the axis of the slow tidal dance the two of them have been performing for billions of years, locked face to face, each forever showing the other the same hemisphere, turning together like two dancers who long ago stopped letting go. And that is a very specific place to land. Think about it the way an astronomer has to. If you take a world and you punch a great basin into it at random, a stray impact, a chance blow from the early chaos of the solar system, that scar could end up anywhere, any latitude, any longitude, wherever the incoming body happened to strike. There are countless places it could be. And yet this one, the largest, brightest, most important feature on the entire surface, came to rest almost exactly on the one meaningful line the whole system possesses: the tidal axis. The spine of the Pluto-Charon relationship that is either the most convenient coincidence in the outer solar system, or it is not a coincidence at all. It is a clue. A fingerprint left at the scene. And the moment you decide it's a fingerprint, you're forced to explain how a feature gets to sit on that axis, and the explanation the scientists reached for is beautiful and unsettling in equal measure. They call it true polar wonder. The idea is that the heart did not form where we see it. It formed somewhere else, and then the entire planet slowly rolled. The whole crust and everything on it reorienting itself, the poles migrating, the surface turning like a marble adjusting in its socket, until this one feature slid into place along the tidal line and locked there. The planet rearranged itself to put the heart where the heart now is. But a planet does not just roll for no reason. Something has to be off balance to make a whole world turn over. Some excess of weight in the wrong place, tugged by the tides until it settles where the forces want it. A heavy spot wants to migrate toward that axis, the way a lump of clay stuck to a spinning wheel wants to find its own place in the rotation. So for the heart to have wandered here, the heart must be heavy. It must carry extra mass. It must, in the language of gravity, be a place where a passing spacecraft would feel a little more pull than it expected. And this is the knot at the center of the whole mystery, the thing that turns a pretty Valentine into a genuine problem that has divided serious scientists for years. Because Sputnik Planitia is a basin, a hole, a great sunken plain lying kilometers below the terrain around it. And a hole, by every ordinary instinct you have, should weigh less, not more. Scoop a valley out of the ground, and you have removed material, taken mass away, left a deficit where solid rock or ice used to be. A pit is lighter than the land it interrupts. That is simply how holes work. So here is the contradiction, laid bare. To have wandered to the tidal axis, the heart needs to be a place of extra weight. But the heart is a deep basin, which ought to be a place of missing weight. The evidence points two ways at once. The position says heavy, the shape says light. And both cannot simply be true, not without something hidden, filling in the gap between them. Something down in the dark below the ice that we cannot see and have never touched, quietly adding the weight that the surface refuses to explain. You can feel, can't you, how the question stops being about scenery and starts being about what lies underneath. That is the real doorway here. Not the colour of the ice or the smoothness of the plain, but the invisible thing beneath it that would have to exist to make the arithmetic balance. Because if the basin is a hole, and yet the basin is heavy, then someone has to hide a great mass down there, out of sight, in a place no camera has ever reached and no drill will reach in any of our lifetimes. And the argument over what that hidden mass actually is, that is the fault line running straight through this whole frozen world. For years, one answer held the field almost unchallenged. It was elegant. It fit. It quietly turned Pluto from a dead ball of ice into something far stranger and far more alive, and it involved liquid water, real liquid water, kept from freezing in the coldest reaches of the solar system by processes buried deep in the planet's own body. It was the kind of idea that gets repeated so often it begins to sound like a fact, the ocean under the ice, the sea in the dark, stated with a confidence that outran the evidence. And then, not so long ago, a single quiet study came along and suggested that the ocean might not need to be there at all, that the same heavy heart, sitting on the same accusing line, could have been made another way entirely, violently, in an afternoon, by something falling out of the sky at a shallow angle and leaving its own broken body behind. Two stories, one frozen heart, and beneath it, in a darkness we have never seen, either an ocean or an absence, either water or wreckage, and no way yet to tell which. We're going to go down into both of those stories now, slowly, carefully, and I want you to notice, as we do, that neither of them is the tidy answer you might expect. This is not a mystery with a solution waiting politely at the end. It is a live argument, an honest one, between people who have looked at the same pale valley and come away believing opposite things about what sleeps beneath it. So let's begin with the older story, the one that put a sea under the ice, and see how you build an ocean in a place that should be far too cold to hold one. But to understand how an ocean under the ice came to feel necessary at all, you first have to understand the heart itself, not as a shape on a map, not as a landmark named for a man who spent his life searching for it, but as a machine, a slow, cold, enormously patient machine that has been running without interruption for as long as Pluto has been a world, and that will still be running long after everything New Horizons photographed has been consumed and remade and erased. To understand why the ocean was proposed, you have to understand what the ocean was supposed to explain. And to understand that, you have to go down into the heart and follow the ice as it moves. The process has a name: solid-state convection. It sounds technical, and the name will do you no harm if you let it sit there for a moment without worrying over it, because the thing it describes is something you have almost certainly watched in an ordinary kitchen without knowing what you were looking at. Solid-state convection is what happens when a material that appears rigid, that looks, to all outward appearances, like a solid, immovable thing, is actually, over time, over vast reaches of time, flowing, not quickly. Not in any way you could detect with your eyes or your hands or your instruments over the course of a human lifetime, but flowing nonetheless, rising where it is warm and sinking where it is cool, turning over in slow cycles that have nothing dramatic or urgent about them, that simply continue day after day and century after century, as patient and inevitable as gravity. You can watch a simplified version of this on your stove. Fill a pot with something thick, a heavy stew, a pot of oatmeal, anything viscous, and set it on a low flame, and after a while, if you look carefully at the surface, you will see the material beginning to organize itself into lazy cells. Warmer fluid rises in the center of each cell, spreads outward across the surface, cools, and then sinks again at the edges, where it rejoins the warmer material below and begins the cycle again. The cells have distinct boundaries. They hold their shape, and if you dropped a small object into the pot, it would eventually be carried by the slow circulation to the edge of a cell and deposited there, in the boundary between one cell and its neighbor, because that is where the sinking material drags things down. That is what is happening inside Sputnik Planitia, except slower, incomparably slower, and colder. The surface of Pluto sits at roughly 40 Kelvin, which is approximately minus 233 degrees Celsius, a temperature so far below anything in ordinary human experience that the numbers cease to carry their full weight without a moment to let them settle. At that temperature, ordinary water ice is not soft. It is not gentle. It does not flow or yield or bend under pressure on any timescale relevant to a human life or a human civilization. Water ice at 40 Kelvin is essentially rock. It behaves the way granite behaves, the way basalt behaves, the way the bedrock beneath your feet behaves, rigid, unyielding, structurally stable, a foundation rather than a fluid. This is a fact worth holding on to, because it inverts everything you might intuitively expect when you are thinking about ice in the context of cold, frozen worlds. Nitrogen ice is different. Nitrogen is a gas at room temperature, the main component of the air you are breathing right now as you listen to this. On Earth, you never think of nitrogen as something that could be solid, because it freezes at a temperature you will never encounter in daily life. But on Pluto, at 40 Kelvin, nitrogen is not a gas. It is a solid. A pale, faintly translucent solid that covers the floor of Sputnik Planitia in a layer thought to be several kilometers thick. And the remarkable thing about nitrogen ice, the thing that makes it unlike water ice in this environment, is that it is not as rigid as you might expect. At Pluto's temperatures and under Pluto's pressures, nitrogen ice is soft. Not soft in the way butter is soft, not something you could dent with your finger, but soft in the deep geological sense, soft enough that over long enough timescales it can flow. it can creep. It can respond to the subtle pressure differences created by warmth rising from below and coldness pressing down from above. And warmth does rise from below. Pluto is old. It formed more than 4.5 billion years ago, assembled from the same dusty rubble that built the rest of the solar system, and locked inside its rock and silicate core are trace amounts of radioactive elements. Uranium, thorium, potassium that have been slowly, continuously decaying since the world was new, releasing heat in the process. Not much heat, an extraordinarily small amount by any human standard. Nothing that would feel warm to the touch, nothing that would register on any instrument you could hold in your hand. But heat nonetheless, seeping upward through the interior. And the nitrogen ice sitting above the rocky core feels it, faintly, persistently, across millions of years. And that faint warmth, working against the extreme cold of the surface above, creates exactly the conditions that drive convection in the pot on the stove, warmer material below, cooler material above, and a substance just plastic enough to respond. The result is the polygonal cells. From the altitude at which New Horizons passed on that July morning in 2015, the surface of Sputnik Planitia looks like something alive, something cellular in the biological sense, something you might expect to see under a microscope rather than from the window of a spacecraft crossing the outer solar system. The plane is divided into a mosaic of irregular polygons, each one ranging from roughly 10 to 40 kilometers across, so that the largest of them, set side by side, would stretch from the center of a major city past its outermost suburbs and halfway into the countryside beyond. The polygons are separated by shallow troughs, gentle depressions in the ice that trace the boundaries between neighboring cells, the places where the cooler nitrogen is sinking back down, and in the centers of the cells the ice rises imperceptibly slowly and spreads outward toward those troughs. The overturned timescale, the time it takes for a given parcel of nitrogen ice to rise, spread, cool, and descend, is thought to run at a few centimeters per year. A few centimeters. The length of a fingernail growing. And yet across the span of Pluto's history, across the billions of years this process has been running, and the hundreds of thousands of years of each individual overturned cycle, those centimeters accumulate into something planetary. They add up into the reason Sputnik Planitia is crater-free. They add up into the reason the surface you are imagining right now, the bright pale plane divided into its patient polygons, is estimated to be no older than roughly 500,000 years, younger than our own species, younger than the oldest stone tools found in the African earth, younger than the emergence of anatomically modern human beings on this planet. On a world that is 4.5 billion years old, that is not merely recent. That is, in geological terms, this morning. When a meteorite strikes Sputnik Planitia and punches a crater into the nitrogen ice, the convection cells close over it. The warmer nitrogen rises around the disruption, the colder material sinks into the gap, and the crater is gradually consumed, smoothed over, incorporated into the slow circulation, until no trace of the impact remains on the surface. The world forgets the wound. It does not scar. And so when you look at the image New Horizons returned, that impossibly smooth, impossibly bright plane with its tessellating polygonal cells and its complete absence of craters, you are not looking at a surface that was never struck. You are looking at a surface that has been struck countless times and has forgotten every single one of those strikes, because the mechanism of forgetting has been running longer than the memory of any individual event, and it is still running. right now, in the dark and the cold, with no one watching. This was the work of William Mackinnon and his colleagues, published in Nature in 2016, laying out in careful detail the mechanism by which Sputnik Planitia erases itself and the properties of the nitrogen ice that make it possible. The key insight, and it is worth pausing on this because it is genuinely strange, is that the roles of the two kinds of ice are the opposite of what intuition suggests. You would expect, perhaps, that the water ice would be the soft and flowing material, because water ice is what you know, what you have held in your hands, what melts in a glass on a summer afternoon. And you would expect the nitrogen ice to be something more exotic, harder, different. But at Pluto's temperatures, the situation is reversed. Water ice is the bedrock. Nitrogen ice is the glacier. Water ice is the basement beneath the house. Nitrogen ice is the moving thing, the breathing thing, the thing that responds to heat and cold and time and slowly reorganizes itself on a timescale that makes mountain building on Earth seem hurried. It is a role reversal that Pluto enforces with absolute indifference to what seems logical from this side of the solar system. And the consequences of that role reversal are visible right at the edges of Sputnik Planitia, in the feature that more than almost any other in the New Horizons data captures something of the alien strangeness of this world. Along the northwestern margin of the Great Basin, where the smooth nitrogen plain meets the rugged upland terrain beyond it, there are mountains. Real mountains, jagged, irregular, rising several kilometers above the surrounding surface. And they are made of water ice. They are called the Al-Idrisi Montes. The name honors Muhammad al-Idrisi, the 12th century Arab geographer who drew one of the most accurate maps of the world produced in the medieval period, a man who spent his life charting the shapes of lands and waters on a planet he knew was round. It is an appropriate name, in its way, for a feature that turned out to be one of the most geographically unexpected things in the outer solar system, because those water ice mountains are floating. Not in any dramatic or obvious sense, not bobbing visibly on a liquid surface the way a boat bobs on a harbour. The movement is geological, invisible in any human time frame. But the physics is the same. Water ice is less dense than nitrogen ice. A block of water ice sitting on a surface of nitrogen ice will, over time, tend to rise just as a piece of wood. Denser than water, but less dense than stone, will float if you place it in a river. The blocks of the Al-Idrisi Montes, some of them tens of kilometers across, masses of frozen water that rise kilometers into Pluto's thin sky, are sitting atop the nitrogen plain, and the slow convective movement of the nitrogen beneath them is, over the same unimaginable timescales, working on them, carrying them, sorting them. Where the convection cells rise in the center and spread outward, the material moves toward the troughs at the cell boundaries. Anything floating on the surface of the nitrogen is carried along in that slow drift. And so the water ice blocks, these mountains that seem so fixed, so permanent, so indifferent to motion, are being jostled, slowly, toward the edges of the convection cells. They accumulate at the margins, pushed there by the same process that pushes the foam on a pot of simmering soup toward the edges of the pot. They cluster at the cell boundaries, piling up in places, grinding against one another in the geological equivalent of slow motion, and the troughs between the cells become, over time, the gathering places of everything the convection cannot carry downward, the bedrock that is too buoyant to sink, the rocky flotsam of a frozen world. The image of this, mountains floating, Mountains being slowly herded across a surface by the invisible hand of convecting ice is one that repays sitting with. It is easy when you are dealing with timescales of hundreds of thousands of years. To let the action collapse into abstraction, to file it away as something that happens but cannot really be imagined. But the mechanism is the same mechanism as the pot. The physics is the same physics as the harbour. The mountains float, and they drift, and the world beneath them turns over with a patience that makes patience itself seem impatient. And the result is visible in the data that took 16 months to arrive from a spacecraft receding into the outer dark at 14 kilometers per second. Beyond the floating mountains, at other edges and margins of the basin, the geology of Sputnik Planitia is doing something else, something that feels more familiar, in the sense that it echoes a process most people on Earth have seen, or at least seen images of, glacial flow. To the east of Sputnik Planitia, the terrain rises. The smooth, pale plain gives way to older, rougher ground, highlands and upland plateaus made largely of water-ice bedrock, that rigid, granite-like stuff, and carrying on their surfaces the dark, reddish tints of ancient tholin deposits. The chemical residue of millions of years of ultraviolet light falling on methane and nitrogen and rearranging the molecules into something more complex and more coloured. And from those highlands, nitrogen flows down. It flows the way glaciers flow on Earth, in the large-scale sense, in the sense of vast bodies of ice moving under their own weight toward lower ground, following the valleys and channels carved by older geological processes, spreading where the terrain opens and narrowing where it squeezes between ridges. The nitrogen glaciers on Pluto are not the fast-moving temperate glaciers of Iceland or the coastal ranges of Alaska. They are slower still than those already slow rivers of ice, because Pluto's gravity is weak. Only about 1/15 of Earth's, and the driving force of the nitrogen's own weight is correspondingly gentle. But the flow is real. The textures in the New Horizons images show it, the characteristic surface patterns of glacial movement, the subtle striations, the way the ice organizes itself as it moves, the way it fills the lowland basin of Sputnik Planitia, the way water fills a basin, flowing to the lowest point and pooling there, contributing to the thick nitrogen layer that the convection cells are continuously turning over. So Sputnik Planitia is being fed from two directions at once. It is being refreshed from within by the slow overturn of the convection cells that consume its surface and resurface it every 500,000 years. And it is being fed from without by the nitrogen glaciers descending from the eastern highlands, carrying fresh ice into the basin from the uplands above. The plain is not static. It is not simply a feature that formed once and then sat there, unchanging, waiting for a spacecraft to photograph it. It is a dynamic system, a slow-motion process, a machine with multiple moving parts, all of them operating on timescales that dwarf anything in human history, but are, by the standards of a 4.5 billion-year-old world, extraordinarily rapid. And because it is a machine, because it is dynamic, it has effects that extend beyond the plane itself. The nitrogen in Sputnik Planitia does not simply sit in the basin and convect and receive the glaciers from the east. It sublimes, it evaporates, in the very particular sense that solids can evaporate directly into gas when the conditions are right, when the pressure is low and the temperature is adequate, even if that temperature is, by any human reckoning, brutally cold. On the sunlit side of Sputnik Planitia, the nitrogen ice absorbs enough faint warmth from the distant sun to transition directly from solid into vapor, rising invisibly into the thin atmosphere above. On the shadowed side, where the temperature is even lower, the vapor condenses back out of the atmosphere and settles onto the surface again as fresh ice. The plane breathes. It inhales in the dark and exhales in the light, and this breathing drives currents in the thin atmosphere above, patterns of wind that organize themselves around the basin's presence, and those winds carry things. But we are moving too quickly now, and the night is still long, and there is more to see inside the heart before we step back and look at the larger world around it. So stay a moment longer in the plane. Stay with the convection cells and their slow polygonal churning, with the mountains of water ice floating at the margins and the glaciers descending from the east, with the surface that is being continuously consumed and continuously remade. Stay with the strange fact that this is happening right now, that at this very moment as you lie still in the dark and the warmth, that cold pale plane 4.5 billion kilometers from the sun is turning over, millimeter by patient millimeter, erasing the record of everything that has ever fallen on it, preparing the surface for whatever comes next. There is something in that fact that has a quality the scientists who study it sometimes struggle to articulate, because it runs against a deep and somewhat comforting assumption we carry about the outer solar system. The assumption that far from the sun means frozen still, means changeless, means dead. Pluto was supposed to be the monument to that assumption. It was supposed to be the cold, inert relic at the edge of the solar system, a world that formed and then simply sat there, slowly cooling, slowly becoming more and more fixed in whatever shape it had acquired in its earliest hours. The demotion from planet to dwarf planet in 2006 carried with it a kind of rhetorical diminishment that made this assumption easier to hold. A dwarf planet is smaller, less important, less consequential, less likely to have anything interesting still happening on its surface. And then New Horizons arrived, and the heart was there, and the heart was not dead. It would be several more years before the full range of what New Horizons had captured was understood, because the data came back so slowly that 1.2 kilobits per second crawl across 4.5 billion kilometers of empty space, the full dataset taking 16 months to arrive in its entirety, a trickle of information that scientists had to read and interpret in batches. Each new batch opening a new layer of something that nobody had predicted. But even the earliest images made it clear that the assumption was wrong, that Pluto was not what it was supposed to be, and that the heart sitting pale and enormous against the reddish darker surface around it was the most concentrated expression of that wrongness. The smoothness of it, the complete absence of craters in the western lobe, the polygonal texture, the mountains at the margins. These were not the features of a dead world. They were the features of a world that had been awake the whole time, doing something in the dark and the cold, unreachable and unobserved, for longer than there have been complex animals on Earth. And the more you look at it, the more you trace the convection cells back to their heat source, the more you follow the floating mountains back to the physics of density and buoyancy, the more you track the glaciers flowing down from the eastern highlands, the more it becomes clear that the heart is not merely a single feature. It is the center of a system. It is the organizing principle around which several distinct geological processes are simultaneously operating, each one feeding into the others, each one drawing on the same source of slow internal heat and the same extreme cold pressing down from above. The solid-state convection is what produces the smooth surface and the polygonal cells. But those cells do not exist in isolation from the rest of the world. The cell boundaries, those shallow troughs where the cooler nitrogen sinks, are the places where the water ice blocks accumulate, the Al-Idrisi Montes clustering at the margins, guided there by the very process that erases the surface. The convection that smooths the plain and the mountains that edge it are products of the same system, different expressions of the same physics operating at different scales, on different materials with different densities. And the glaciers flowing in from the east are bringing new nitrogen into the basin, replenishing what the convection cells process and what the sublimation breathes off into the atmosphere, completing a cycle of exchange between the surface and the air above that has been running, in some form, for as long as Sputnik Planitia has existed. The basin is a sink and a source simultaneously. It draws in the glaciers from the highlands and releases nitrogen into the atmosphere above, and both of those flows are driven by the same fundamental asymmetry. A basin sitting lower than the surrounding terrain, floored with a material that is just warm enough to be soft and just cold enough to be solid, sitting on a world with just enough internal heat to keep the process going. It is, considered as a system, genuinely beautiful. And it is genuinely strange. Because the strangeness is not just that any of this is happening at all in a place this remote and this cold. The strangeness is also in the inversion of the familiar, in the way Pluto takes the materials and the processes that feel most basic and most straightforward and rearranges their relationships so that what was hard is soft, what was flowing is rigid, what was the surface is the foundation. What was the foundation is the glacier, water ice, which on Earth is the soft thing, the thing that melts, the thing that flows in rivers and carves canyons and retreats before warming temperatures. On Pluto, water ice is the architecture, the cliffs and the mountains and the highlands, the thing that stands, and nitrogen, which on Earth is the invisible thing, the background, the unremarkable majority of the air. On Pluto, nitrogen is the movement, the slow overturning, the thing that breathes and circulates and carries other things with it and erases whatever falls onto its surface by simply, patiently incorporating it. The role reversal is total, and it is not a curiosity, not a footnote. It is the whole operating principle of the heart and everything that happens there. So when scientists in 2016 sat with the New Horizons data and tried to explain not just what the heart was doing, but why the heart was where it was, why Sputnik Planitia sat in that particular location on Pluto's globe, on that particular line, aligned with the tidal axis, in a way that seemed too precise to be accidental, they already knew that the heart was a complex, dynamic, multi-layered thing. They already knew that the plain was not merely a filled crater, not merely a frozen puddle in a dip in the landscape. They knew it was a machine. And machines, when they produce precise and unexpected outputs, often require precise and unexpected inputs. They require an explanation that is as specific as the thing they produce. And the location of Sputnik Planitia is, by any reckoning, a specific and unexpected output. It sits where it sits for a reason, or for what appears, from every angle the data allows, to be a reason. And the question of what that reason is, the question of what force or event or buried structure could have placed a basin of exactly that character on exactly that line, is the question that sent two teams of scientists in 2016 toward an answer that would, for 8 years, feel close enough to certain to be stated as near fact in nearly every popular account of Pluto's interior. The answer they found was elegant. It was specific. It required something hiding in the dark, beneath the ice, that no spacecraft had yet seen and that no measurement had yet confirmed. But we are going to reach that answer properly. And arriving at it properly means understanding first the precise terms of the puzzle it was designed to solve. And those terms, the tidal axis, the mass anomaly, the geometry of a heart that sits where it has no business sitting if the world beneath it is simply frozen rock, those terms deserve their own careful treatment. Which means we are not quite done with the mechanism. We are not quite done with the plane and its churning polygons and its floating mountains and its descending glaciers. There is one more thing the convection does, one more consequence that follows directly from the slow overturning of the nitrogen ice, from the way the material rises and spreads and cools and sinks in its patient, enormous cells across the floor of the basin. And it is this: the overturn has a rate, a few centimeters per year. And when you multiply that rate by the size of the cells, 10 to 40 kilometers across, and by the thickness of the nitrogen layer, several kilometers deep, you get a cycle time, a period. The time it takes for a given volume of nitrogen ice to complete one full circulation, rising from the warm base of the layer to the cold surface, and then sinking back down. That cycle time is roughly 500,000 years, and that cycle time is the reason the surface is crater-free. Because if an impact creates a crater that is, say, a kilometer deep, and the convection is turning over the upper few kilometers of ice on a 500,000-year cycle, then the crater will be consumed within that cycle. It will be buried, surrounded, overtaken by the slow flow of the surrounding ice, which has no awareness of the disruption and no interest in preserving it, which simply continues to circulate as it has always circulated, because the heat is still there below and the cold is still there above, and the nitrogen is still soft enough to flow. The crater is not healed, it is erased. The distinction matters. Healing implies the surface returns to what it was before. Erasure implies the surface becomes something new, something that has no memory of the wound, something that has simply moved on. Sputnik Planitia does not heal. It forgets. And it will go on forgetting for as long as Pluto retains enough residual heat to keep the nitrogen just barely soft enough to move, which, by the calculations of the scientists who model these things, is still a very long time. The heart is not near the end of its cycle. It is not winding down. The convection is ongoing. The erasure is ongoing. The next 500,000 years will be exactly like the last 500,000 years. The cells will turn over, the mountains will drift, the glaciers will flow, the surface will be remade, and whatever records have accumulated in the ice, whatever craters, whatever chemical deposits, whatever traces of whatever passed above or fell below, will be consumed and forgotten and lost. This is the heart. This is what it does. This is the machine running in the dark at the edge of the solar system, while everything else in the inner planets argues about politics and constructs its monuments and tells itself it is permanent. And now, with the mechanism held in your mind, the convection cells, the floating mountains, the descending glaciers, the 500,000-year overturn, the nitrogen soft where water is rigid, the plane erasing whatever falls on it with a patience that makes patience seem hasty, now we can begin to ask the harder question. Not how the heart erases itself. That we have. But why the heart is where it is. Why that machine, that specific geological feature with all its specific properties, ended up sitting on that specific line. and what has to be true about the world beneath it for that alignment to make any sense at all. Because the alignment is not a coincidence, or if it is the most expensive coincidence in planetary science. The kind of coincidence that demands, in the minds of scientists who study such things, an explanation. And the explanation that came first, the one that held the field for 8 years, required something extraordinary buried beneath the ice. Something liquid. Something that should not, by any simple accounting of the temperature and the distance from the sun, be possible. But there is more world to see before we follow that question underground, and it is worth seeing, not as a detour, not as a distraction from the deeper mystery, but because the full picture of what Pluto is changes the weight of that mystery considerably. The heart is the most visible proof that this world is alive. It is not the only proof, and the other proofs are strange in their own ways, strange in directions you would not quite predict, strange in the way that real things are strange when they refuse to arrange themselves into the tidy categories that seemed so reliable from a distance of 5 billion kilometers. Look up. When New Horizons turned its instruments away from the surface and looked sideways, looked at the curved horizon where the dark body of Pluto meets the absolute black of space, it found something in the sky. Not a blank, thin atmospheric shell the way many had imagined it. Not simply the trace suggestion of gas clinging to a small frozen body too cold and too far from the sun to hold very much. What it found was a series of haze layers, stacked delicately, one above another, reaching upward to roughly 200 kilometers above the surface. Around 20 distinct layers counted in the returned images, each one thin, each one separate, each one suspended in the tenuous nitrogen air like a veil hung in a room where nobody has moved anything in a very long time. And they were blue. This was not what anyone expected. The haze particles responsible for those layers are called tholins. They are reddish-brown organic molecules, complicated carbon-rich compounds, and they form when ultraviolet light from the sun and cosmic rays from deep space break apart the methane and nitrogen molecules in the upper atmosphere, splitting them and reassembling the fragments into something more complex. Tholins are not a single molecule. They are a family of results, a consequence of chemistry running on very long timescales, with very weak energy in very cold conditions, producing compounds that have no single clean name and that do not exist in any meaningful quantity anywhere in the inner solar system. They coat the surfaces of small, distant, cold objects throughout the outer solar system. And in the images from New Horizons, they painted the darker regions of Pluto in shades of rust and ochre and deep amber. But in the haze layers overhead, those same tholins produce blue. Not because the particles themselves are blue, they are not, but because they are small. Small enough that the way they scatter sunlight mimics with quiet precision. The way Earth's own atmosphere scatters sunlight, the shorter wavelengths, the blue end of the spectrum, bouncing more efficiently off the tiny particles and bending toward the camera, while the longer red wavelengths pass through more directly. The same physics that gives Earth its familiar daytime sky operates here above a world so cold and so remote that the comparison seems almost implausible. And yet there it is, a blue haze over Pluto. 20 layers of it, stacked in the dark, scattered in a light that has travelled so far it arrives here as barely more than a whisper. The haze, it turned out, does more than simply exist. A 2017 study, led by Zhang and published in Nature, found that those haze particles play an active role in regulating Pluto's atmospheric temperature. For some time before New Horizons arrived, models of Pluto's upper atmosphere had predicted it should be considerably warmer than what the spacecraft actually measured. There was a gap, a discrepancy between what the physics suggested ought to be there and what was actually there, and it needed explaining. The answer, Zhang and colleagues proposed, was the haze itself. The tholin particles cool the atmosphere. They absorb energy and radiate it away in infrared, acting as a kind of planetary thermostat, a mechanism built from the byproducts of their own creation that turns around and moderates the conditions of the environment where they were made. The haze regulates Pluto's sky the way a thick curtain of insulation regulates the inside of a very old, very quiet house. Remove it, and the temperatures would shift. Keep it, and the atmosphere holds itself in a particular balance that the particles themselves are largely responsible for maintaining. This is a closed loop of a peculiar kind. Methane and nitrogen are broken apart to make tholins. The tholins form haze. The haze cools the atmosphere. A cooler atmosphere affects how gases move and how much methane reaches the upper layers to be broken apart into more tholins. The whole process feeds back on itself over timescales that make the word cycle feel inadequate, because a cycle implies something that completes and returns, and this system is more like a current, a tendency. A slow drift maintained by its own byproducts across a distance from the Sun, where most things that Earth would recognize as chemistry have simply stopped. And what the haze makes eventually falls. Tholins form in the upper atmosphere, and, over time, they settle. They drift downward through the stacked blue layers, growing as they travel, clumping with other particles. And eventually they reach the surface. Where they land, they stay, they accumulate. They build up over the long Pluto seasons, each season a full Plutonian year, 248 Earth years long, a single orbit around the Sun that begins and ends at a distance so great the Sun looks from here like a very bright star and nothing more. Over those seasons, in those places on Pluto's surface that are old enough and stable enough to hold what falls on them, the tholins paint the ground. To the west of Sputnik Planitia, roughly speaking in the direction that an Earth-bound observer might call northwest, if they were willing to apply those terms very loosely to a world whose orientation is itself a matter of some scientific significance, there is a region that is dark. Very dark. Dark in the way that old things sometimes are dark. The darkness of something that has been accumulating for a very long time without anything coming along to disturb or refresh it. This region is called Cthulhu Macula. The name, borrowed from the fictional cosmic horror of H.P. Lovecraft's imagination, was chosen partly for the shape of the region and partly, one suspects, for the quality of unease it inspires. Though the real place requires no fictional horror to be genuinely strange. It stretches for roughly 3,000 kilometers. It is ancient. Its surface is heavily cratered, crater upon crater, accumulated over billions of years, the impact record of a world that was once simply sitting in the solar system and absorbing whatever the solar system threw at it without any internal process to wipe the slate clean. Cthulhu Macula is what a crater-saturated, ancient surface looks like when tholins rain down on it for long enough, a deep, reddish-brown stain on the face of the world, the colour of old rust or the skin of certain very old pears, left too long in a bowl, and it speaks, in the way geological regions speak, in the language of accumulated evidence that planetary scientists learn to read, of a surface that has not been renewed, of a surface that is old, very old, perhaps as old as Pluto itself. And this is why the contrast matters so much, because the heart is next door to Cthulhu Macula, roughly speaking. Sputnik Planitia and its bright nitrogen ice and its crater-free churning surface sit in the same neighborhood as a region that shows every crater it has ever received. The two regions are almost side by side, and they could hardly be more different. One is a machine of continuous renewal, erasing its own history every 500,000 years with the patient efficiency of a system that has been running without interruption since long before anything on Earth had yet learned to breathe. The other is an archive, a slow accumulation of every strike, every event, every piece of the ancient solar system that found its way to Pluto and left a mark. The bright and the dark, the young and the old, sitting next to each other on the same world, and between them the record of everything that has and has not changed in 4.5 billion years. And the tholins do not stop at Pluto. Pluto's atmosphere is thin, but it leaks. Molecules at its outer edges, methane especially, escape the world entirely, drifting out into the space between Pluto and its largest moon. Charon orbits Pluto at a distance of roughly 19,000 kilometers, and the two worlds are tidally locked to each other, each keeping the same face permanently toward the other, so that Pluto's Charon-facing hemisphere always sees the moon, and the moon always sees Pluto in the same place in its sky. The methane that escapes Pluto's atmosphere in this direction drifts across that gap, and when it reaches Charon, which has no significant atmosphere of its own, which is much colder at its poles than at its equator, which has a north polar region that spends long years in unbroken darkness during Charon's long polar winter, it freezes. The methane settles onto Charon's cold north pole as a thin frost. And then, when the long polar night ends and sunlight returns to that pole, the ultraviolet light and the cosmic rays do what they always do to methane: they break it apart, and they rebuild the pieces into tholins. Red-brown organic molecules accumulate on the surface of Charon's north pole, building up over time into a permanent stain. New Horizons imaged it clearly. Charon's North Pole is marked by a dark reddish region informally named Mordor Macula. And Mordor Macula was not made by Charon, it was made by Pluto. The methane that escaped Pluto's gravity travelled through the vacuum between the two worlds, froze onto Charon's pole, and was processed by sunlight into something that cannot be undone. That is what colours Charon's northern cap. Two worlds connected across nearly 20,000 kilometres of space by the quiet chemistry of escaping breath. Pluto exhales, and its largest moon turns red from it. The two worlds are chemically entangled in a way that, once seen, makes the idea of them as separate and isolated objects seem insufficient. They are in conversation. They have always been in conversation. The conversation is just slower than anything we usually think of as a conversation, and the vocabulary it uses is not words but molecules and radiation and time. Bring your attention now closer to the surface and closer to the heart, because along the northwestern edge of Sputnik Planitia, where the convecting nitrogen plane meets the mountains of water ice, where the Idrisimontas rise and bob and are jostled by the slow cellular motion of the ice beneath them, the terrain is interesting in an additional way that nobody quite anticipated before New Horizons arrived. In 2018, a study led by Matt Telfer and published in the journal Science, reported something in the images from that region that required careful looking, and after careful looking, required explaining. Dunes. Not dunes made of sand, the way dunes are made on Earth. Not wind-blown silica grains organizing themselves into the familiar crests and troughs of a desert landscape. The grains here are made of methane ice, tiny particles of frozen methane, roughly 200 to 300 micrometers across, about the size of coarse sand, which is to say not large at all, barely visible as individual grains, arranged in regularly spaced parallel ridges near the boundary between the mountains and the plain, oriented in a way that suggests they have been organized and placed there by wind. Wind on Pluto, which has an atmosphere 100,000 times thinner than Earth's, in which the surface pressure is around 10 microbars against Earth's 1,000 millibars at sea level, a difference so large that the word thin entirely fails to convey it, in which the atmosphere might partially freeze out entirely as Pluto moves farther from the Sun along its long, elliptical, 248-year orbit, collapsing from an already barely there gas into a frost on the ground. And yet, the dunes are there. The modelling that accompanied the Telfer study suggested that winds of several tens of kilometers per hour, gentle by any Earth standard, manageable, the kind of breeze you might not bother to mention in a weather report, could be sufficient, given the geometry of the mountains and the way the air moves across the plain near the Al Idrisi Montes, to transport and deposit those methane ice grains. And the mechanism by which grains get lofted into even that thin air in the first place is probably sublimation, where methane ice on the surface transitions directly from solid to gas in Pluto's weak sunlight. The expanding gas can kick surrounding grains upward into the flow, passing them to the wind, which carries them and sets them down in organized rows. Sand dunes built from methane ice by barely there wind through a process driven by the direct conversion of ice into vapor. On a world so cold that nitrogen is soft and water ice is stone. The solar system, it turns out, is under no obligation to find wind-driven dune formation as surprising as we do. It simply runs the physics wherever the physics can run. Move now from the plain, move away from the dunes and the mountains and the slow blue haze above, and travel to the southwest. Or rather, because direction on Pluto requires a certain looseness of definition, when you are trying to imagine it from the inside, from the ground, looking out, travel to a region of Pluto that New Horizons imaged and that scientists, when they studied those images, found themselves unable to classify without careful deliberation and some degree of hedged language. There are two large mounds. The larger of the two is called Right Mons. It is roughly 150 kilometers wide and rises to somewhere between 4 and 5 kilometers above the surrounding terrain. At its summit there is a large central depression, a hole, a pit, a feature that in the language of planetary geology is called a central edifice depression. The other mound is called Picard Mons, and it is large as well, though less thoroughly characterized. Both features sit in Pluto's southern hemisphere, south of the heart, in a region that was imaged with sufficient resolution for their shapes to be visible and their dimensions to be estimated with some confidence. The reason these mounds require careful language, the reason that scientists writing about them use phrases like candidate cryovolcanoes and interpreted as rather than simply stating what they appear to be, is that the evidence, while suggestive, while consistent with a particular interpretation, does not yet amount to proof of eruption in the way that planetary scientists mean proof. A 2022 analysis led by Kelsey Singer and published in Nature Communications looked at Right Mons and the terrain surrounding it with particular attention and argued that the hummocky, mounded landscape surrounding the edifice looks consistent with material that was emplaced volcanically, and that this emplacement may have been geologically recent, by which they meant recent in geological terms. Not last year, not last century, but within the last several 100 million years or so, which on a 4.5 billion-year-old world is recent in the same sense that the Heart's 500,000-year surface is recent. The surrounding terrain, in Singer and colleagues' assessment, does not look like impact ejecta or tectonic disruption. It looks like it was placed there by a process from below. If the interpretation is correct, and it remains an interpretation, a strong hypothesis with supporting evidence rather than a settled conclusion, then what erupted from Right Mons and Picard Mons was not lava in any sense that would be recognizable to someone standing near a terrestrial volcano. There is no liquid rock here. The erupted material would have been a slush, a mixture of water ice and ammonia, or water ice and other compounds that lower the melting point enough to allow something that is mostly water to move while at temperatures far below water's ordinary freezing point. Cryovolcanism, ice volcanism, the eruption of cold materials from the interior of a world too cold and too small for the usual volcanic machinery, is a process that has been proposed for several outer solar system bodies, including the moons of Saturn and Neptune, and finding possible evidence of it on Pluto adds the dwarf planet to that list, provisionally, with the appropriate caveats intact. Something large and cold and slow may have welled up from beneath the surface of Pluto and spread itself across the southern landscape. The depression at Right Mons' summit is where the material would have come from, or where the edifice collapsed after the material left. Neither interpretation is certain. The mounds are there. Their shape is real. What made them is still being argued. And then, farther east, and here, again, directions serve as loose orientations, approximate headings to help the imagination find its way across a world it has never visited. There is a region that received one of the more evocative informal names in the entire New Horizons dataset. It is called Tartarus Dorsa. And what makes Tartarus Dorsa worth noticing, worth spending time with in the dark, is that it is covered with blades. Not metaphorical blades, not a landscape that resembles blades in some loose, poetic sense. Actual blade, like ridges of methane ice, aligned roughly parallel to one another, rising to heights of several hundred meters, separated by valleys between them, covering a large area of Pluto's surface in a pattern so regular and so geometric that it looks, in the New Horizons images, like the surface of a brain, or like the scales of something very large and very old, or like the surface of a planet-scale piece of corduroy stretched out across the ground. The informal nickname the scientists applied to this terrain was the bladed terrain, or the snakeskin terrain, or the brain terrain. Multiple names. All of them arriving at the same observation that the surface here does not look like the surface of anything that feels familiar. The mechanism that made these blades has a terrestrial analogue, though the analogue exists on Earth only at high altitude, where conditions approach, very distantly, some fraction of the strangeness of Pluto. On Earth, in the high Andes and other equatorial mountains above a certain elevation, snowfields sometimes develop into tall, pointed spikes of ice called penitentes, named by European explorers for their resemblance to a procession of hooded penitents. They form when sublimation, the direct conversion of ice to water vapor in dry air under direct sunlight, acts unevenly across a snowfield, eating away at some areas faster than others, and leaving the less sublimated material standing as ridges and spikes. The process is called differential sublimation, and on Earth it produces penitentes that might stand a meter or two tall in the most extreme cases. On Pluto, Tartarus dorsa's methane ice blades reach hundreds of meters. The scale difference reflects the vast difference in the timescales involved, and in the extreme conditions, the temperature, the nature of the ice, the particular geometry of sunlight arriving at that distance from the Sun across that long, slow orbit. But the fundamental mechanism is the same one operating at a completely different order of magnitude. Sunlight, even the faint and distant sunlight that reaches Pluto, has been patiently carving the methane ice of the eastern uplands into blade-like ridges over timescales long enough that the result stands hundreds of meters tall and extends across a region large enough to be visible from the altitude at which New Horizons made its pass. Two worlds, Pluto and those Andean peaks, sharing a process. The universe reusing its mechanisms across scales and distances that the mind must work to span. Now pull back from the blades and the volcanic mounds and the dunes and the dark stain of Cthulhu macula and the blue haze overhead with its 20 stacked layers and its thermostat tholins. Pull back from all of it and hold the full world in mind at once. Hold the whole picture, a world at 40 below 200 degrees Celsius. In nitrogen air 100,000 times thinner than the air on Earth, with glaciers moving and mountains floating and volcanoes possibly erupting and blades of ice hundreds of meters tall standing against whatever passes for wind, and over it all a blue haze settling slowly down as the complex chemistry of the outer solar system does quietly what the inner solar system is too warm and too energetic to attempt. Hold all of that, and then consider what the heart does to it. In 2020, a study led by Tanguy Bertrand examined what happens to Pluto's atmosphere when you remove Sputnik Planitia from the equations, when you cover the heart in their climate model, and ask what the global wind circulation would look like without it. The result was unambiguous in its implications. With Sputnik Planitia present, Pluto's atmospheric circulation has a particular pattern, a particular set of preferred directions and intensities, winds moving in specific ways across the surface in response to the sublimation and condensation of nitrogen ice. Nitrogen sublimates, converts from solid to gas on the warmer, sunlit side of the basin. It is transported by the atmosphere. It condenses, returns from gas to solid on the colder, shadowed side, depositing as frost. And this cycle, this constant movement of nitrogen vapor from one side of the heart to the other and back again over the course of each Pluto day and each Pluto season, is not merely a local phenomenon confined to the basin itself. It drives the atmospheric circulation of the entire world. Cover the heart in the model, and the wind pattern reverses. The whole atmospheric engine, such as it is, such as it can be in that thin and barely there sky, is organized around Sputnik Planitia. The heart beats, in other words, in the way that hearts beat, by moving things. Not blood, not cells, nitrogen gas, in quantities that would be negligible by any Earth measure, moved through an atmosphere so thin that a human standing in it would be in vacuum for all practical purposes. But moved nonetheless. Organized, directed, the basin that erases its own surface every 500,000 years is also, simultaneously, the engine that organizes the wind that carries the atmosphere above. Remove it and Pluto's weather, to use that word very loosely, as it must always be used loosely here, falls into a different pattern entirely. The feature that looks like a heart in the albedo map, that bright teardrop-shaped region that was one of the first things New Horizons cameras resolved into something recognizable, is not merely decorative. It is functional. It is, in a very real physical sense, the heart of the world. Not metaphorically. Mechanically, it regulates, it circulates, it maintains a particular atmospheric state that would not exist without it. And yet, for all that the heart does, for all the erasing and the wind driving and the floating mountains and the descending glaciers, and the way its nitrogen convects over the heat of ancient radioactive rocks in the dark, it sits where it sits. It sits on that particular point on Pluto's surface, that particular longitude and latitude. The point that has drawn the attention of planetary scientists more than any other single fact about the world. The point almost exactly facing Charon. The point almost exactly on the tidal axis between the two tidally locked worlds, that line drawn between their centers of gravity, the line that defines the geometry of their eternal face-to-face orientation. That point, that position, is the thing that does not go away. The heart is alive. The heart is driving weather and erasing history and doing all the things we have spent the last while learning that it does. And it is doing all of those things from exactly the place where something with exactly the heart's properties of mass and depth and density would need to be if the world's orientation were determined by a buried secret. A secret that sits beneath the ice, beneath the rock, deep in the interior of a world that has let no spacecraft close enough to probe it since the morning of July 14th, 2015, and to which no spacecraft is currently heading. A secret that may be liquid and may be enormous, and may be the most astonishing fact about the most astonishing geological feature in the outer solar system. Or maybe something else entirely. Something that requires no water at all, and no ocean, and no liquid of any kind. Only a very particular kind of ancient violence, and a very particular kind of rocky remnant from that violence, still sitting buried in the ice, invisible, doing exactly what an ocean would do from the outside, while being, in its nature, something completely different. The question is which? The question is what is actually there. And it is a question that, as the world is colder and quieter, and the haze settles in its blue layers, and the blades of Tartarus Dorsa stand in the dark, and Right Mons holds its depression open at whatever it is, neither erupting nor entirely still, sits unanswered at the center of everything Pluto has shown us. And so there are two answers, two complete, internally consistent, mathematically workable answers to the question of why Sputnik Planitia sits where it sits. And the fact that there are two of them, and that neither has yet been able to displace the other, is the honest state of our knowledge of the world that is more than 5 billion kilometers away. The world whose complete dataset took 16 months to arrive home at a trickle of 1 to 2 kilobits per second over a radio channel that required 4.5 hours just to carry a signal from there to here. Two answers, and no way yet to reach between them and say with certainty which one is true. The first answer is the older one. It came in 2016, in the months after the data began to accumulate, when planetary scientists started working through the implications of Sputnik Planitia's position and found that the position was asking a question they had not expected. The question was this: how does a massive depression end up sitting almost exactly on the tidal axis between Pluto and its moon? Think of what the tidal axis means. Charon is large relative to Pluto, large enough that the two worlds are locked face to face, each showing the same hemisphere to the other at all times, the way our moon always shows us the same face, but amplified, symmetrical, mutual. The line connecting their centers runs straight through both worlds, and the point on Pluto's surface directly beneath Charon. And the point on the opposite side of Pluto, directly away from Charon, are the two poles of what scientists call the Pluto-Charon tidal axis. Those 2 points are gravitationally special. A mass sitting near either of them exerts a stabilizing influence on the planet's orientation, a pull that tends to keep the planet from wandering. A heavy thing that ends up near the tidal axis tends to stay near the tidal axis because the gravitational relationship between the two worlds makes that position the lowest energy configuration. Sputnik Planitia sits almost precisely at one of those points. Its center lies very close to the Pluto-Charon tidal axis, near 25 degrees north latitude on the hemisphere that faces away from Charon, not perfectly on the axis, but close enough that the probability of this being an accident, a random impact landing by chance in exactly that geometrically favored location, is very small. Small enough that scientists in 2016 were unwilling to call it coincidence and be done with it. There is a mechanism that can move a large mass from wherever it originally formed or struck to the tidal axis, and that mechanism is called true polar wander. It is not the kind of polar wander you might be thinking of, the slow drift of Earth's rotational axis relative to the stars over millennia. True polar wander is something more dramatic and more total. It is the reorientation of a planet's entire body relative to its spin axis. The physical rotation of the crust and mantle around the interior until a heavy feature migrates toward the equatorial bulge, or in Pluto's case, toward the gravitational low that the tidal lock with Charon creates. If you place a heavy weight on the surface of a spinning world, and if the world's interior is soft enough to allow it, the planet will eventually rotate beneath its own spin axis until the heavy weight arrives at the most gravitationally stable position. The planet finds its balance, the way a top-heavy object tips until its center of gravity drops as low as it can go. For true polar wander to carry Sputnik Planitia to the tidal axis, the basin must be a mass excess. It must weigh more than the average surroundings, generating a gravitational signal that the planet's rotational dynamics can respond to. And here is where the answer gets complicated, because a basin is a hole. Sputnik Planitia sits 2 to 4 kilometers below the surrounding terrain. Empty, it would be a deficit, a region of missing material, gravitationally lighter than the surroundings. For it to be a mass excess, something must be filling that deficit and then adding more. Something must be present inside or beneath the basin whose density more than compensates for the missing rock above. The 2016 papers by Francis Nimmo and colleagues and by James Keane and colleagues, published in Nature, proposed a specific candidate for what that something is: a subsurface liquid water ocean. The idea works like this. The impact that created Sputnik Planitia punched through Pluto's water ice crust and thinned it locally, perhaps breaching it, or at minimum leaving it far thinner beneath the basin than elsewhere on the planet. If there is a liquid ocean beneath that ice shell, the thinning of the shell would allow the dense liquid water to bulge upward beneath the basin floor, a dome of liquid pressing up into the space where the thicker ice used to be. Liquid water is denser than ice. This is the same reason ice floats in a glass, because it is less dense than the liquid it came from. And so a dome of liquid water rising beneath a thinned ice shell represents a local concentration of mass relative to the thicker ice surroundings. Then you add the nitrogen ice filling the basin from above. Nitrogen ice at Pluto's temperatures, several kilometers of it, is itself a significant mass. The combination of a liquid water upwelling beneath and a deep nitrogen fill above produces a net mass excess over the basin, a positive gravity anomaly, what geophysicists call a mascon, from the phrase mass concentration. And a mascon of the right magnitude, placed at the right latitude, can drive the true polar wander that would reorient Pluto and bring Sputnik Planitia to rest on the tidal axis where we find it. The implied ocean is not small. To generate the required mass excess and drive the required reorientation, the models suggested a liquid layer possibly more than 100 kilometers deep, lying beneath an ice shell tens of kilometers thick. An ocean huger than the basin above it, quiet and dark, insulated by its own shell, and kept at least partially liquid by the remnant heat flowing upward from Pluto's rocky interior. The long, slow warmth of radioactive decay in the rocks that settled to Pluto's core over the 4.5 billion years of its existence. An ocean that has never seen sunlight, never been touched by anything from outside, sealed beneath kilometers of ice, and perhaps kilometers of nitrogen ice and rock above that. There is more to the ocean model than the basin's position and the polar wander mathematics. There is what you might call the testimony of the fractures. Across Pluto's surface, New Horizons observed a system of long tectonic faults, extensional faults, the kind that form when a surface is being pulled apart and stretched rather than compressed. The most prominent of these are named Virgil fossae and Sleipnir fossae, long rifts and troughs visible in the New Horizons images. On Earth, extensional tectonics often signal a hot interior pushing outward or a body being pulled apart by tidal forces. On Pluto, the most natural explanation is something specific, a subsurface ocean that is slowly, over geological time, freezing from the outside in. When water freezes, it expands. This is why pipes burst in winter, why ice cubes occupy slightly more volume than the water they were made from. An ocean beneath Pluto's ice shell that has been gradually freezing over billions of years would expand as it froze, pushing outward against the overlying ice crust, stretching it, cracking it, producing exactly the pattern of extensional faults that New Horizons recorded. The cracks in Pluto's surface on this reading are the sound of a hidden ocean slowly crystallizing in the dark, its volume growing by a fraction of a percent each million years, but that fraction adding up over billions of years to enough force to split the surface and leave the rifts visible from 12,000 kilometers overhead. The extensional faults are independent of the basin's position and the polar wander argument. They are a separate line of evidence, and they point in the same direction. Something beneath the surface has been pushing outward for a long time. The ocean model accounts for them naturally. A world with no ocean, no liquid interior, must find another explanation for the rifts. Or accept that the explanation is less elegant, less unified, less satisfying in the way that a single hypothesis explaining multiple independent observations is satisfying. And yet, in April 2024, a team led by Harry Ballantyne and Martin Jutzi at the University of Bern published a paper in Nature Astronomy that proposed exactly such an alternative. A model that explains Sputnik Planitia's position, its shape, and its mass anomaly without any liquid water at all. It reproduces the evidence from a different direction entirely, using only ancient geometry and ancient violence. And it leaves the question of what lies beneath Pluto's heart genuinely, uncomfortably, unresolvably open. The 2024 paper begins with shape. If you look at Sputnik Planitia carefully, it is not round. A large impact by an object arriving roughly vertically, striking the surface at a steep angle, produces a roughly circular crater. Think of the craters on the Moon. The great circular basins that astronomy students trace on maps, their circularity the signature of a symmetric impact event. Sputnik Planitia is not circular. It is elongated and tear-shaped, something like a teardrop, wider at one end and narrowing at the other, with a tail trailing away in a specific direction. A symmetric impact does not naturally produce this geometry. Something about Sputnik Planitia's formation was not symmetric. Ballantyne, Jutzi, and their collaborators ran numerical simulations of impacts into a Pluto-sized body, varying the angle of the impacting object and the speed at which it struck, and they found that a specific class of impacts reproduces the teardrop shape with remarkable fidelity, a low-angle, low-velocity oblique impact. A shallow-angle collision at perhaps 30 degrees or less from the horizontal rather than a steep, nearly vertical strike. They describe this in terms that are easier to visualize than they might first appear. Imagine throwing a ball at a slightly soft surface, not straight down, but at a shallow, skimming angle, so that the ball does not punch straight in, but skims across and smears its momentum out along a direction, leaving an elongated asymmetric mark rather than a neat round hole. Scale that up by every factor you need to account for a body more than 700 kilometers across, arriving at the speed of a slow solar system encounter, and the simulation produces a depression whose shape matches Sputnik Planitia closely. The elongation, the teardrop asymmetry, the way the basin widens at the direction the impactor came from and narrows to a tail pointing back along its path. But shape is only part of what the splat model explains. The more consequential claim is what the oblique impact leaves behind. When an impactor arrives at a shallow angle rather than plunging straight in, it does not simply excavate the target and scatter debris outwards symmetrically. The impactor's own body, its crust, its mantle, its core, if it has differentiated sufficiently to have one, is deformed and distributed across the impact site in a way that is fundamentally different from a vertical strike. In particular, the dense, rocky core of the impactor does not simply vaporize or scatter to the edges. In the simulations Ballantyne and Jutzi ran, the rocky core of the impacting body, dense, heavy, compact, is carried along by the oblique momentum and deposited directly onto Pluto's own core, buried deep in the target body, merged with or pressed against the rocky interior of Pluto rather than spread across the surface or lost to space. The impactor's core becomes a buried mass concentration, what geophysicists call a mascon, sitting deep inside Pluto at the location of the impact. Invisible from the surface, exerting no geological effect that would distinguish it from an ocean to any instrument New Horizons could carry on a single flyby at 12,000 kilometers. A buried rocky mascon of the right size and density could produce exactly the positive gravity anomaly that the polar wander models require. The math is different from the ocean model's math. The mass is rock instead of liquid water. It sits deeper rather than just beneath a thinned ice shell. It was created in a moment of violence rather than accumulated slowly over billions of years. But the gravitational signal at the surface, the net positive anomaly, is the same. Pluto's crust and mantle, experiencing that anomaly from the inside, would reorient in the same way. True polar wander would carry the basin to the tidal axis by the same mechanism, driven by a mascon with no liquid water in it at all. The teardrop's tail points in the direction the impactor came from. This is a testable geometric claim. Testable, that is. If you have a spacecraft with a gravity mapping instrument in orbit around Pluto, which we do not, but it is a specific prediction, a fingerprint left in the shape of the basin itself. The ocean model has no analogous geometric fingerprint in the basin's outline, because the ocean model's mechanics operate internally and symmetrically. If the basin's elongation and the direction of its tail can be shown to correspond to a specific impactor trajectory, the splat model gains a form of evidence the ocean model cannot provide. And the extensional faults? The splat model must address them, or concede that the tectonic evidence favours the ocean. Ballantyne and Jutzi acknowledged the faults in their paper and noted that extensional tectonics on Pluto does not require a liquid ocean as its explanation. Other processes, including cooling and contraction of the deep interior over time, or the dynamics of a rocky mascon embedded in an icy planet and responding differently to tidal stresses from Charon, could potentially produce surface tension and fracturing. The ocean model explains the faults more simply and directly, and ocean proponents have noted this. But the splat model does not require the faults to be impossible without an ocean. It requires only that the faults be explainable without one. This is where the dispute sits. Not in disagreement over the observations, both camps accept the same crater-free basin, the same tidal axis position, the same teardrop shape, the same extensional faults. The disagreement is in the interpretation of those observations, in which physical model more naturally, more completely, more elegantly accounts for all of them at once. The ocean model accounts for the position and for the faults with a single underlying cause. The splat model accounts for the position and for the shape with a single underlying event and handles the faults separately. Both fit the data that New Horizons returned. Neither has been proven wrong. It is worth sitting with that for a moment at this hour in whatever quiet your night has found. Both models fit the data. The question of whether Pluto hides a liquid water ocean right now, tonight, in the dark below the nitrogen ice, is not a question that science has answered. It is not a question that science has come close enough to answering to call one side the favourite and the other the long shot. The 2016 ocean model was, for 8 years, the dominant interpretation, the one most planetary scientists would have cited as the best current explanation. The 2024 splat paper is not a fringe challenge, it is a serious, peer-reviewed piece of work from a credible research group using state-of-the-art impact simulations published in one of the major planetary science journals. It does not overturn the ocean model, but it demonstrates, clearly and specifically, that an oceanless Pluto is consistent with everything we have seen, and that the ocean's existence is not required by the evidence. What would settle it? A gravity map of sufficient resolution to distinguish between a dense, rocky mascon sitting deep in the core and the subtler, shallower, differently shaped gravity signal of a liquid water ocean pressing against the underside of the ice. A seismic measurement, the way we probe Earth's interior with earthquakes and map the interfaces between rock and liquid, adapted somehow to Pluto's alien geology. A long enough orbital survey to detect the slight wobble that a large subsurface liquid layer would impart to Pluto's rotation over time versus the more rigid response of a world with no liquid interior. Any of these measurements would in principle be decisive. None of them is currently being made. There is no spacecraft on its way to Pluto. New Horizons, after the flyby, continued outward into the Kuiper Belt and visited another object in 2019, the contact binary Arakoth, and is now travelling deeper into the outer solar system, still functioning but not pointed at Pluto, its mission to the dwarf planet complete in the single pass of July 14, 2015. Plans for a Pluto orbiter have been discussed and proposed and studied by NASA. Mission designers. A dedicated orbiter that would spend years mapping Pluto from close orbit, measuring its gravity field precisely, watching its geological behavior across seasons, carrying instruments capable of probing the interior in ways that a fast flyby could not. But as of the time this narration is being assembled, no such mission has been funded and approved. The instruments that could settle the ocean question do not exist yet at Pluto, and the political and financial machinery required to get them there has not yet been set in motion. That means the dispute between the ocean model and the splat model will not be resolved soon. It will be open for years, possibly decades. The scientists working on Pluto will continue to analyze the New Horizons dataset, continue to run simulations, continue to build new theoretical frameworks and test them against the measurements that exist. But the definitive answer, the measurement that eliminates one model and vindicates the other, requires hardware at Pluto. And hardware at Pluto requires political will and budget cycles, and the slow, uncertain work of getting a spacecraft across 5 billion kilometers of space. That takes, as New Horizons itself demonstrated, approximately 9.5 years after launch. And that is before counting the years of proposal and development before the launch itself. And in the meantime, the heart is doing what the heart does. The convection cells are turning. Nitrogen ice is rising in the centers of those great polygons, spreading outward, cooling, sinking at the margins, erasing whatever crater or scratch or fresh deposit falls onto the surface by burying it in slow, cold, inexorable circulation. The surface that New Horizons photographed in such extraordinary detail, the one that took 16 months to transmit home at the rate of a slow dial-up connection from the early years of the Internet, requiring 4.5 hours just for the light from each signal to travel from the antenna to Earth. That surface is already different. Not dramatically different, not noticeably different to any instrument we could send today, because the overturn timescale is 500,000 years, and we have observed for only 11 since the flyby. But incrementally, cell by cell, centimetre per year, the heart is replacing itself. 500,000 years from now, the surface of Sputnik Planitia will be unrecognizable compared to the images stored in NASA's archives from 2015. Every detail that planetary scientists have spent the years since the flyby studying, every polygon boundary and every textured trough between the cells, and every smear of reddish tholin blown onto the bright nitrogen ice from the surrounding terrain, all of it will be gone. New surfaces will have risen from the warm depths beneath, new nitrogen crystals condensed and settled into new patterns, new cells opened and opened again. The heart will still be bright, it will still be churning, but it will not be the same heart that New Horizons saw. The self-erasing has not paused for us, and will not pause for whatever instrument might eventually arrive. There is something about that fact that is worth feeling as well as understanding. The most detailed image we have ever made of any place in the outer solar system beyond Neptune, the closest look humanity has taken at Pluto's surface, is a photograph of a temporary arrangement, a snapshot of a moment in the middle of a process that began long before any human civilization existed and will continue long after our current ones have been replaced by whatever comes next. The heart of Pluto was erasing itself before the pyramids were built. It was erasing itself before the first human beings arrived in the Americas. It was erasing itself before the continents of Earth had settled into anything like the configuration we would recognize on a map. And it will be erasing itself, calmly, continuously, at a few centimeters a year, long after the records we have made of it are indistinguishable from noise, in whatever information system a million years from now is using to store things. There is also the other side of the dispute's open verdict, the possibility that the ocean model is right, and that beneath the churning nitrogen, beneath the thinned water-ice bedrock of the basin floor, there is a layer of liquid water that has been there since the early solar system and has not yet frozen completely. If that is true, then Pluto is one of a small number of worlds in the solar system that currently host liquid water, a list that includes Earth and the ocean believed to exist beneath the ice of Jupiter's moon Europa, and the ocean confirmed to exist beneath the ice of Saturn's moon Enceladus, and the possible oceans that may lurk beneath the surfaces of other moons of Jupiter and Saturn, and possibly of Titan. The habitable ocean worlds, if that term is allowed its quiet, aspirational weight. If Pluto's subsurface ocean exists, it adds the edge of the solar system to that list, the most distant, the coldest, the least obviously promising entry. Whether liquid water in Pluto's interior could support anything like life is a question that belongs to a different conversation, and probably to instruments and spacecraft and investigations that have not yet been built. The answer is genuinely unknown in both directions. There is no evidence that it could, and there is no evidence that it could not, in part because no one has been able to sample it or even confirm that it exists. But the ocean model, if it is correct, implies that liquid water has persisted in Pluto's interior for billions of years, kept from freezing by the slow warmth of radioactive decay deep in the rocky core, and perhaps by an insulating layer of some kind between the rock and the ocean. Billions of years is a long time. On Earth, life established itself in the oceans within the first billion years or so of the planet's history, and has had somewhere between 3 and 4 billion years since then to explore and diversify and colonize every environment available to it. Whether any of that logic applies to a dark, cold, entirely sealed ocean beneath the surface of a dwarf planet at 40 degrees above absolute zero, not the ocean's own temperature, because a liquid ocean beneath an ice shell is kept warmer than that by pressure and by the heat rising from below, is not something anyone can currently say. The SPLAT model, by contrast, does not leave room for that question. If Ballantyne and Jutzi are right, the mascon beneath Sputnik Planitia is a knot of dense rock, the compressed, merged core of an ancient impactor that struck at a shallow angle and left its bones buried in Pluto's interior. Rock, not water. Cold, not warm in the sense that matters for liquid. A geological fact, not a potential harbour for anything. A dead thing from a violent past, doing its work gravitationally and remaining otherwise silent. The ocean model offers the wilder possibility. The SPLAT model offers the colder, simpler one. Science, in the end, will follow the evidence rather than the preference, and the evidence needed to choose is not yet in hand. What is in hand, and what will not be taken away by future missions or future papers, regardless of how the ocean question resolves, is the picture of Pluto as a world that is alive. Not alive in the biological sense, not yet, not provably, perhaps not at all. but alive in the geological sense, deeply and irreducibly active, a world that is doing things that it was not supposed to be able to do at 4 billion years of age and 5 billion kilometers from the sun. A world that erases its own surface, that floats mountains of water ice on a glacial sea of nitrogen, that sends its own breath out across the black to paint a dark stain on the face of its moon, that organizes sand-sized grains of methane ice into dunes and builds towers of ice that stand hundreds of meters high and layers haze above haze in blue strata that extend 200 kilometers into a sky too thin to breathe. That may or may not hide an ocean. That may be a crime scene from an oblique ancient impact, or maybe a world with a deep, cold, living sea. All of that is certain. The aliveness of Pluto is not in dispute. The dispute is only about the deepest interior, the layer that no light has ever touched and no instrument has yet measured. Everything above that layer, the churning heart, the floating mountains, the haze thermostat, the atmospheric tides that reverse if you cover the plane in models, the tholins snowing onto old red terrain, the cryovolcanic candidates with their central depressions, the bladed fields of methane, the glaciers flowing downhill, and the extensional cracks, and the single dark polar stain on Charon, 1 billion kilometers overhead. All of that is real, confirmed, observed, studied, and still being understood from a dataset that took 9.5 years to collect and 16 months to deliver, and that remains the only direct, close-up observation humanity has ever made of Pluto. One pass, one morning, one spacecraft traveling at 14 kilometers per second through 12,000 kilometers of closest approach, carrying instruments that had 9.5 years of cruise time and a few tense hours of closest approach in which to gather everything we know. It was enough to overturn almost everything we thought we knew and replace it with a set of questions that are more interesting than the certainties they displaced. That is, perhaps, what the outer solar system is for. Not to confirm what we already understand, but to show us that the scale of what we do not understand is larger than we estimated. The heart is out there tonight. Right now, at whatever distance the geometry of the solar system has carried it since the 14th of July 2015, Sputnik Planitia is doing what it does. The nitrogen cells are rising and falling in the dark. The mountains of water ice are floating at the margins. The haze is building in its 20-odd layers above the thin, cold atmosphere. The tholins are snowing down onto Cthulhu macula, adding another imperceptible fraction of a millimeter to the old, dark red surface that has been accumulating its ancient craters and its drifting chemistry for far longer than the young, bright heart beside it. And whatever is beneath the basin, ocean or rock, mascon or water, the consequence of ancient freezing expansion or ancient oblique violence, is sitting there, as it has been sitting since before the earth had continents, doing its work in the dark and keeping its secret. The answer is not yet known. It may not be known in our lifetimes. That is not a failure of science. It is the honest condition of working at the frontier, where the instruments have not yet caught up to the questions. The questions are there, real and specific and technically addressable, waiting for the mission that has not yet been funded, for the spacecraft that has not yet been built, for the trajectory that has not yet been calculated, for the morning some decades from now, when another closest approach burns itself into the cameras of another probe, and the data begins its long, slow trickle home, at whatever speed a 2040s or 2050s transmitter can manage across 5 billion kilometers of nothing. Until then, the heart keeps erasing itself, and the mystery underneath it keeps its silence. If you have stayed with this long enough to find yourself here, in whatever dark corner of the night you are occupying, whether it is the middle of the night in a city that has gone quiet, or the early hours in a place where the stars are still out, or a room that has gradually grown still around you, while this story of a cold, distant, improbably alive world has been keeping you company, I would genuinely like to know where in the world you are listening from tonight. The comments are there, and I read them, and there is something I find genuinely moving about knowing that a story about a 5 billion kilometre distant dwarf planet and its self-erasing heart has found its way to exactly wherever you are, whatever latitude and longitude you happen to inhabit on this warmer, livelier, more familiar world. There are more stories here of the same slow and careful kind, other quiet mysteries from the edges of what we know, other places where the evidence runs out and the question remains open and the night feels appropriately large around it. They are here whenever you want them, waiting without urgency. But for now, Sputnik Planitia is turning in the dark. The haze is settling in its blue layers. The mascon or the ocean or whatever it is continues its long, patient work beneath everything, holding the heart in place on the tidal axis as the world rotates and the years pass and no spacecraft approaches. The nitrogen ice rises and cools and sinks and rises again. The blades of Tartarus dorsa stand in the cold and the dark. Hundreds of meters of methane ice shaped by the slow sublimation of a Pluto summer into forms that have no name in any earthly language, because nothing like them exists anywhere else we have been. The frozen old red terrain of Cthulhu Macula holds its ancient craters, each one a record of a collision so old it predates any story anyone has ever told. While beside it, the young, bright heart carries no craters at all, only the present, only the motion, only the ongoing work of being geologically alive at the edge of the solar system. You have spent enough of this night thinking about the cold and the dark and the far. The mystery will still be there tomorrow, still unresolved, still patient, still waiting for the instruments and the missions and the scientists who will eventually come. Let it wait. It is good at waiting. Good night from up here in orbit. I'll keep watch while you drift.